Welcome to today's class. Today we'll be talking about experimental and theoretical probability. In the last class we discussed the basics of probability, where we defined event, experiment, outcome, sample space, and some other major definitions. Right, for today's class we'll be talking about first the experimental probability. I'm taking some examples on that. Okay, now don't forget that we said probability is what? Number of required outcome over sample space, that is total number of all possible outcomes. Therefore, we define experimental probability as number of required outcome over number of possible outcomes. Now let's take one example under that. When we say experimental probability, it means something you experiment. You actually did it, to practice it. A die is rolled 200 times. Can you see this? The outcome obtained as shown below, that is the number of times that one showed after rolling the die for 200 times, is 25. One showed 25 times, two showed 30 times, and three showed 45 times, 4 28, 5 40, and 6 32 times. Now we have to find the experimental probability of obtaining a 6 and a 2. First, if we have to find the probability of the die showing a 6. Now, how many times did it show a 6? It showed a 6 32 times out of 200. So simply, you just say number of required outcome is what? They asked us to find the number of times that 6 showed. So the required outcome from us is what? Number of times 6 showed, which is what? 32. And sample space is what? 200. It's in the question. A die is rolled 200 times. How many times did we roll? 200. That is the sample space. So we say 32 over 200. That is E over S. 32 over 200. And as I said, that probability must be expressed in the lowest terms. So you have 4 over 25, or you leave it in decimal domain, which is what? 0.16. Now for B, it says probability of it showing a 2. From the table, you can see that it showed a 2 for 30 times. 2 was shown for 30 times. So number of times 2 showed, that's what? 30 over sample space, which is what? 200. Can you see it there? So we have 30 over 200, which in the lowest term is 3 over 20. That gives us 0.15. I believe that's clear. Okay, I said note this, since the experimental probability uses numerical records of past events. Of course, if you say, oh, I performed the experiment, it must be in the past. Of past events to predict the future, its predictions are not absolutely accurate, since we only use the past records. However, the probability of throwing a 2 on a first 6 die is 1 over 6. Since any one of the 6 faces is equally unlike, I told you the meaning of equally unlike, that is every part of the die, every face of the die has equal number of probability, that is of showing itself. 1 2 3 4 5 6 have equal probability of showing. Now this is an example of, so let's take an example of theoretical probability. Now don't forget that for the experimental probability, it makes use of past events, while the theoretical probability predicts the future. I said this probability is okay. It should be okay. Theoretical probability is the assumed value assigned to the occurrence of an event based on the assumption that each of the elements in the outcome are equally likely to happen. That is, by considering the physical nature of the given situation. Let's take one example for more understanding. Example 1 says, Tola throws a first 6-sided die. What is the probability that she throws a 9, a 4, a number greater than 2, an even number, either 1, 2, 3, 4, 5, or 6? So let's solve for A. Since the faces, now, okay, probability of she throwing a 9. Now, the first thing you do to solve any probability question is to what? Find the sample space. For a first 6-face die, we have 6 as sample space, because we have 1 2 3 4 5 6. Number of entries are 6, so or is 6 now. Okay, so now if she must throw a 9 is not in the sample space. Therefore, that's probability of what? Uncertainty. I told you in last class that probability of assurance or certainty is 1. Probability of uncertainty that it can never happen is what? 0. So since 9 cannot show when you throw a 6 face die, then probability of it showing a 9 is 0. I believe that's clear. B. Probability of showing a 4. Of course, we have only one 4 out of 6. Therefore, the probability is 1/6. Now the event is what? Number of events is 1. That is to show a 4. 1 out of 6. 1/6. Now for C, probability of showing a number greater than 2. Now the sample space we have consists of 1, 2, 3, 4, 5, 6. Now numbers that are more than 2 are 3, 4, 5, 6. That is 4 out of 6. Do you understand? So probability of it showing a 2 is number of it showing showing a number greater than 2 is the number of figures greater than 2 over total number in the sample space. So we have 3, 4, 5, 6, that's 4 numbers. So 4/6. That gives us 2/3. I believe that's clear. D. We also asked to show or find the probability of she throwing an even number. If she must throw an even number, it means she must either throw a 2, a 4, or a 6. Now, amidst this sample space, we have 3 numbers that are even. Therefore, we have 3 out of 6. That gives us 3/6, which is 1/2. I believe that's clear. Number of even over number of sample space. Now, E. What is the probability that she throws either a 1, 2, 3, 4, 5, or 6? Now, whenever you see all in sample space in a probability question, it means you add. Probability of it showing a 1 is 1/6, of 2 1/6, of 3 1/6, of 4 1/6, of 5 1/6, of 6 1/6. If you add all this together, all the 1/6, 1/6, 1/6, we get 6/6. That gives us 1. Now, or you say, since number of required outcome is that it shows 1 to 6. Can you see that? And the numbers in 1 to 6 is 6. Also, number in sample space is also 1 to 6. 6/6 gives us 1. Very simple. Probability of the required outcome is probability of it showing a 6 over number in sample space is also 6. So 6 out of 6 gives 1. That's clear, I think. Example 2. A bag contains 3 red, 5 green, 7 white balls. If a ball is selected from the bag, what is the probability that the ball is green? Now, the first thing you need to do is what? Find the sample space. Add the number of balls you have together. We have 3 plus 5 plus 7. That gives 8 plus 7, which is 15. Now, the first thing you need to do, sample space is 15. Now, what are they requiring of us to do? So let's find the number of required outcome. What is the probability that the ball is green? So you find number of green or total number of balls. So how many green balls do we have there? We have 5 green balls. That's what. Don't forget that the required outcome is also called the event. So number of the event, which is number of required outcome over number of entries in sample space, might give us 5 out of 15, which is 1/3 in lower term. I believe that is clear. Good. Let's quickly take. So these are your evaluation. Now that we've discussed about the experimental and the theoretical probability, let's look at some things that you might meet in exams. Evaluation. Use the figure below to answer the following. We have these numbers in this box or on this table. Now, it says if a number is picked at random from the figure, what is the probability that it is odd? What will you do? Count all the numbers there. Then, if you have 4 times 1, you have 16 numbers there. Now you count the odd ones. For instance, if you count and you have 5 odds, that's 5 out of 16. That's 5/16. Prime, of course, look for the prime numbers. Don't forget that 1 is not a prime number because that's only one factor. All prime numbers have 2 factors, 1 and themselves. So you count the prime numbers over total number of entries. That's the probability. Even, same thing. Less than 10, the same thing. Exactly divisible by 3. Don't forget, number like 10 is not divisible by 3, but 12, 15, these are numbers what? Divisible by 3. and even 3 itself. So you look for them, then add them together over total number of numbers in the table. A perfect square. A perfect square is a number that has a whole number square root. Like what? Like 4 having 2 as a square root. Like what again? 100 having 10 as a square root. Like 144 having 12. Like 169 having 13, etc. So you look for the perfect squares in this table over the number of total entries. A perfect cube or cube. Good one. Now, a perfect cube are numbers that have a whole number cube root. For instance, we have 3 as a cube root of 9. So 9 is a perfect cube. Can you see that? Because it's 3. Sorry, not 9. Sorry, a perfect cube at 27. Sorry, 3 times 3 times 3. Can you see that? 8 is perfect cube as well, having 2 as its cube root. 2 times 2, 4 times 2, 8. So you look for those numbers there. Alright, for B, if a row or column is picked at random from the figure, what is the probability that the total of its number is 34? If you add the column and the row, you will get 34 for each column and each row. So it means that probability is what? Probability of assurance. I want to take the answer. Now for 35, you can never add and get 35, so you should know the probability. That's simple. Okay, let's look at general evaluation. 1. A bag contains 5 black balls, 5 green balls, and 4 red balls. A ball is picked from the bag at random. What is the probability that it is a black? That's simple. Add all the numbers, all the number of balls. Then how many blacks do we have for our total number? A yellow, a green. That's simple. Now, where I'm going to is not black. What is the probability that the ball picked is not a black? Probability. I gave you a note in the last class that probability of a number p is equal to 1 minus p prime. That is, probability of not something is 1 minus that it is that thing. For instance, probability that the ball picked is not a black is 1 minus probability that it is a black. So the first thing to do is what? Find the probability that it's a black, which is what? 5 out of how many balls now? Okay, we have 5 plus 3, 8 plus 4, 12. So that's 5 over 12. Then you do 1 minus 5 over 12, which is 7 over 12. That's a hint. Now, either black or red. When you see either or something in probability, or means addition. So either black or red, you find probability of it that it is a black, then plus probability that it is a red, because it's all you add together. I think that's simple. Alright, you also have your weekend assignments to do. Look at them here. Likewise, you have your theory for the weekend assignment. Okay, you also have your reading assignment in that text. Your Nigerian Maths verses 2, the page is given and exercise. Please make sure you do it accordingly. I hope the class is clear. Thank you.